So hey guys, I hope all of you are doing well now. And so if you are here in this video means you are pretty sure that you have to nail down data structure. So today I will be discussing a very fast way. I memorized each of the concepts here. So first one is stack. So stack, the only thing which you remember is that stack that it is a single dimensional array, SDD. Okay, so learn it this way. And the next and the only thing which you have to remember is that you have a bucket and you have bricks inside it. So it's a simply the given example in the book. You have bricks inside me, so these are bricks. You see. So this is the thing you have to remember, that there is a bucket and you have bricks inside it. Okay. So I hope the green color is quite visible. To white. Okay. So simply, so the what do you understand by this? That simply that we have uh, a simple single dimensional array which is open because the bucket which contains the brick is open only from one end. So we see that it is open only from one end, from one end. Okay. So it's open only from one end, and the next thing which we see is that uh, if you need to take out, suppose these bricks have covered the whole area, then you can take out a brick. If you want to take out a brick, you have to take it out from the top, means you will take out this brick first and then this brick. Okay, so that's a pretty simple thing, that if you in case you need to take out something, you have to take it out from the top. Okay, so we will say only elements. So for SDD, the what does a SDD contains? It contains elements. SDD contains elements at the top, can be be accessed, and you will see that, or you can say it as it is written in our book, that you cannot access elements from middle. Means from middle. From okay. So now let's make these things a bit smaller and contain them in a point. Okay. So done. Okay, so these are done. So what for stack simple SDD, single dimensional array, and what we have to do is that it should be SDA right now, single dimensional array. Okay, so bricks only Buckets and bricks. Open means bucket is only open from one end. Only elements at the top can be accessed, or you can say that you cannot access elements from the middle of the array. Okay. So this thing is called that elements. Then you notice that the brick which you kept at the last is the brick which you will be taking out at the first. So that's what we mean when we say it follows LIFO concept. Follows LIFO concept. Okay. So this is all about SDA which you need to remember. And then the most asked part is uh, how to put about the algorithm. Okay, so for the algorithm we have two parts where we have to push the element into the array, and one way where we have to pull out an element from the array. Push the element means inserting an element in that array, and that array here is, in this case, it's a stack, and pulling out is called popping. Okay, so the next thing which we are going to try is that writing the algorithm. So for the push operation, we just basically need to check for one condition, that is it's overflow, because overflow means as the name suggests that the bucket has already been filled to its maximum. Then we will see that we cannot fill it more, so then the push operation is not possible in that case. Hence we say that it's a condition of overflow. So to check this, we have to just assume that we have to item I, as it's mentioned in the book. I is our item to be pushed to the stack. Okay, and size is the capacity of the stack. Size is the capacity of the stack. So then we can make out few parts of the problem with this statement, that the overflow, we cannot push. Pushing is not possible. So from this statement it is clear that we have to first check whether it's a overflow or not. Then only we can pushing, not possible. And then we have to then we as when they then we will continue to write if I'm starting this with the statement size is equal to sp, and the sp here is simply our pointer to which uh, sp here is the pointer, and it starts from the topmost element. So topmost brick, you can understand that is simply a pointer. And now the next thing is that we'll check is that we will simply say display, and in terms of Java we write SOPLN. So simply we'll simplify it and write, because algorithm is for every kind of language, display overflow, or you can write stack overflow as well. Stack overflow. And then to simply break, instead of break means we are using return. So return, when no value is returning and we are just writing return and there is a semicolon, we say that it's a kind of break statement. It works as a kind of statement to terminate. So the so the program will terminate in any language. It will terminate and the user will have to restart. Suppose it is given the user cannot input a number greater than 1000, so we'll say that whenever the input crosses 1000, we say we can return it by displaying a particular message. So here that particular message was overflow. Okay, so next thing we have to do is to increase our, if it's not overflow, then what we will do, we will increase the stack pointer. Okay, so next thing will be increase the stack pointer, means xp++, or in sort normal sense it's some algorithm, we'll have to write it like this: sp is equal to sp plus 1. Okay, so next thing which we will do is we will have to just, means we will go one element above, means suppose the third place was empty and the stack, the sp, the pointer was pointing towards the topmost element and this place was empty, so the pointer always points towards the topmost element. So the pointer was pointing towards 2, so we added 1 and made it point towards the empty position, and so we got this position. Okay, so next, like an array, we do stack sp, make sure that these are square brackets, not curved brackets. So just stack sp is equal to the item we have to put. It's that simple. Okay, so that's for the part of pushing. And then after doing our work, in order to terminate, we write return. So that's the way, and that's all. Well, see, first we have to check for overflow, which we did by saying that if size is equal to, let me make this also white as it's a part of the program. So if size is equal to sp, then we display overflow and then return, and then sp is equal to sp plus 1, we say 2 is greater than 3, stack sp, the I stack sp is equal to item. Okay, so first check for overflow, then the uppermost position, then the position above the, then we have to take the pointer to the position above the topmost element before the topmost brick. So topmost brick, it's there in the second position, so we have to put one a brick above it, one new brick above it, so we will go to one position above it. So we do sp is equal to sp plus 1, and then simply we got the position where we have to insert that item, then simply like an array we will write. And another thing, at last, we just remember that you have to use return statement whenever you need to terminate the program. So that's for the pushing part, the inserting part. Now let's move on to the removing part, which is known as pop. So pop means when there will be a pop has like overflow in case of push, pop has a term called underflow. So this happens when there is no element. Underflow, as the name suggests, that there is underflow of elements. So here for underflow we will check that if the pointer is pointing towards null. Null is just the position before the first position. Suppose in our array our first position is 0, so null will be the position after it, means just below it. Okay, so this is the null position. So this is the null position. So if the pointer is pointing at that position, if, let me go with white for the main algorithm part. If the pointer, which is sp, is pointing towards null, then we say, then in terms SOP means the SOPLN statement. In place of SOPLN statement we write display underflow. Okay, so next thing which we have to do is that next thing which we have to check is that the popped out element. What is the popped out element? And one more thing, since if this condition satisfies, then we have to terminate the program. So as I said, for terminating the program, instead of break, use return, because we are more usual to the term break for terminating the program. So we'll write return and just scroll down, and we will say that if then we will come to the part where the condition is not overflow, means there are some elements. Okay, so we will say that we will store the element in which has to be taken out. So this time we will not be given with the element, we will have to take it out. Stack sp. Sp always points the topmost corner, is topmost element. We'll say stack sp, so the topmost element will be removed. And so the next thing is that we'll just display that popped element is popped element is val. Okay, and simply after doing this we will come one pointer down, because suppose the topmost element is 3 and just below it it's 2. So after removing it, the pointer will be pointing to a position where it's empty, so we will have to come down. So that's why this procedure is there. And after finishing everything, you need to terminate the program, so you will write return. So one more thing, that these are not programs, this is just algorithm. So algorithm, as you can see, in place of SOPLN, just remember that we will write display and like that. So that's the way I remember the algorithms for the stack and the concept behind it. Okay, I hope this video was able to help in spite of my laggy speech and weird handwriting. Thank you.